Good morning, Year 9 and 10. This is Radioactivity, Lesson 3. Today's driving question: what is most of the atom made of? Your first task is to label the parts of the atom. Keywords to use are at the bottom: proton, neutron, electron, and nucleus. There is a challenge task to state the relative mass for each particle. Press pause and have a go. Okay, so the answers. For the first one, neutron, the blue particles in the middle. Protons are positively charged, they're the red particles. Electrons are negatively charged in the shells. And the final one is nucleus in the centre. The challenge task, which is state the relative mass for each particle. Proton has a relative atomic mass of 1. Neutron, 1, and electron is much smaller, it's 1/2000th. Okay, we're now going to watch a video on the history of the atom, so how the atom has changed the model of what we think it looks like over the past few hundred years.
It was the ancient Greek philosopher Democritus, or possibly his pupil Leucippus, who first hypothesized that matter was made up of particles that couldn't be split. The word atom comes from the Greek word atomos, which means indivisible.
For a long time, it was believed that atoms truly were indivisible, that they were the fundamental building blocks of nature. Around the start of the 20th century, the physicist J.J. Thomson discovered that it was possible to cause atoms to emit cathode rays, which are beams of electrons. If the electrons were coming from the atoms, then that meant that atoms must contain electrons, and are therefore not fundamental. The atoms must be made up of smaller particles.
It was originally thought that these negative electrons were embedded in a solid sphere of positive charge like plums in a pudding, giving Thomson's model of the atom its name, the plum pudding model. The amount of positive pudding would cancel out the number of negative plums or electrons.
In 1909, the physicist Ernest Rutherford had two of his colleagues, Hans Geiger and Ernest Marsden, carry out an experiment. They fired alpha particles generated by the radioactive decay of radon gas towards a sheet of gold foil and measured the angle through which these alpha particles were deflected.
Much to their surprise, Geiger and Marsden discovered that some of the alpha particles were deflected through very large angles, and in some cases actually back towards the radioactive source. It was, in Rutherford's words, as if you'd fired a 15-inch shell into a piece of tissue paper and it came back and hit you.
The only way to explain the strange results that Geiger and Marsden had obtained was the Rutherford model of the atom, in which the positive charge of the atom was concentrated in a tiny nucleus at the center, with negative electrons orbiting this nucleus at a great distance. Nothing existed in the space between the nucleus and the electrons, making the atom mostly empty space. Because electrons were known to be so light, this meant that nearly all of the atom's mass was concentrated in the nucleus, making the nucleus incredibly dense. A teaspoon of pure nuclei would have a mass of nearly 2 trillion kilograms.
Okay, right, so hinge question. What does the plum pudding model look like? Is it A, solid ball of negative charge, B, contain neutrons spread throughout, C, ball of positive charge with electrons spread throughout, or D, made up of protons, neutrons, and electrons? Pause the video to answer the question. Okay, so the answer is C, ball of positive charge with electrons spread throughout. Next task. Think, pair, share. So think about this on your own. Try and find someone else in your house to discuss your answers with, and then we'll go through the answers. It's a 4-mark exam question. So the first part: in the early part of the 20th century, scientists used the plum pudding model to explain the structure of the atom. There's a diagram. Following work by Rutherford and Marsden, a new model of the atom called the nuclear model was suggested. There's another diagram. So your task is to describe the differences between the two models of the atom. So you can use the diagrams to help you. It's worth 4 marks. Okay, so that means you need to say 4 things. So think about it on your own and then see if you can go and find someone else to have a chat about your answers with and see what they think. Pause the video. Okay, so the answers then. In order to get 4 marks, first mark, nuclear model mass is concentrated at the centre when the nucleus, whereas the plum pudding model mass is evenly distributed. So you need to have both of those comparative sentences to get the mark. Next mark, nuclear model positive charge occupies only a small part of the atom, whereas the plum pudding model positive charge is spread throughout the atom. That's your second mark. Third mark, nuclear model electrons orbit some distance from the centre, whereas the plum pudding model electrons are embedded in the mass of positive charge. It's your third mark. And your fourth mark, nuclear model, the atom, is mainly empty space, whereas the plum pudding model is a solid mass. That's your fourth and final mark. Pause the video to mark your work, please. Okay, so now we're moving on to our main tasks. So there is a template that you can print out, which is on your another assignment on your Show My Homework, which is your sort of extra detail and information. The video we've watched is also on there, as is a bit more information on the 2 different models, a couple of slides if you'd like to use that to help you. So this task you can print out if you have a printer at home. So that's on your Show My Homework, or if you don't have a printer, it would be worth just jotting down the questions and writing your answers in the boxes, or it doesn't need to be in boxes. Okay, so the first task is to label a diagram of the plum pudding model and nuclear model of the atom. Grade 4 to 5, describe the setup for the gold foil experiment and explain what it discovered. Grade 6 to 7, link experimental evidence from the gold foil experiment to the structure of the atom. And grade 8 to 9, compare the plum pudding model to the nuclear model and explain why the model changed. So the orange, green and yellow task can all be done via these questions on this sheet if you have a printer. And the blue one is to compare the plum pudding and the nuclear model and explain why the model changed. So the nuclear model is the one that we did at the very beginning of the lesson. Okay, so pause the video and have a go at the tasks. Okay, so now the answers. Please, if you've got a different colour pen, pick it up and get ready to mark and correct your work. If you feel that you need some extra detail, please add so in a different colour. Okay, so the task sheet, grade 1 to 3. Early plum pudding model was an early model of the structure of the atom. A label diagram could be one like this. Which scientist carried out an experiment to challenge the plum pudding model? That was Ernest Rutherford, Hans Geiger and Ernest Marsden. Need all 3. When did the alpha scattering experiment happen? In 1909. The setup of the experiment, okay, is done by a diagram, or if you'd rather do a description, that's also okay. Evidence that was found, so most particles went straight through the foil, some alpha particles were deflected by small or large angles, and some came straight back. And then grade 6 to 7, what does that evidence mean? So most of the atom must be empty space, as most alpha particles went straight through undeflected. There must be a concentrated positive charge in the centre of the atom, as some particles were deflected. So the alpha particles are positively charged, they would have been repelled. And it's a small positive charge because only a few particles were deflected. Okay, so those are the answers. So press pause to mark, correct, and add any extra detail to your answers. Grade 8 to 9 was comparing the 2 models. So an early model, which was based on a scientific idea on atomic structure, was the plum pudding, so that came first, the diagram on the left. In this model, it was believed the atom was a sphere of positive charge with negatively charged electrons scattered around the atom, like plums in a pudding. Alpha particle scattering experiment was carried out, where alpha particles were directed at gold foil. Most of these alpha particles passed straight through, showing the atom was actually mostly empty space and not like what the plum pudding model suggests. A few alpha particles were deflected at large angles, so the mass is concentrated at the centre of the atom, again contradicting the plum pudding model. And it was concluded then that the nucleus must be positively charged, and therefore the plum pudding model was replaced by the nuclear model. So pause the video to mark and correct your work and add any extra detail. And then finally is your "Today I Achieved" sentence. So Today I achieved state, explain, use or compare, because I can, and then you summarise or write down what's in the boxes next to the part that you have achieved. Press pause to complete your sentence. Okay, don't forget to do your Show My Homework quiz. So remember, there is a 10-question quiz where the results will be emailed to your parents or carers. Please complete that to show that you have done this lesson. Thank you.